Okay, today we are diving deep into tone shaping, really focusing on two pretty legendary pedals. These things let you basically redefine your instrument's voice. We're putting the MXR M109S 6-band EQ head-to-head with its bigger brother, the M108S 10-band EQ. If you've ever, struggled to get your guitar sitting just right in the mix, these might just be the secret weapons.
That's exactly right. And look, these aren't brand new ideas. They're modern takes on some real analog heavy hitters from back in the 70s. Our sources really lay out the key differences: frequencies, power, how you use them. So our mission here is pretty simple. Distill that down so you can figure out if you need that compact, punchy 6-band, or if you need the more kind of surgical, full range control you get with the 10-band.
Right. And we really have to start with what makes both of these pedals kind of instant classics, you know, before we even get into the number of bands.
It really comes down to the circuitry.
Yeah.
Both are built around a genuine, clean, analog signal path. That's important. But even more crucial is that they use active EQ filtering.
Okay, active EQ. What's the distinction there? Why does that matter compared to, say, passive?
Well, passive tone shaping, thing like the tone knob on an old guitar amp, right? That can only really cut frequencies. It attenuates. Active means the circuit has its own power. It's dedicated. It can forcefully lift frequencies up or push them way down with serious precision.
Okay, so passive is like turning down a faucet.
Exactly. And active is like having a pump. You can suck water out or force more in. That active control is why these pedals offer such a massive range of boost and cut.
Okay, so let's unpack that, Bauer. These reissues, the modern ones, they came out around, 2012? They aimed to get that warmth, that analog feel of the originals, but they really tackled the two big complaints people had with the 70s ones, noise and clipping, right?
Precisely. If you had an original M109 or M108 and you started pushing those sliders way up, boost, 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 you hit a ceiling pretty fast. The signal just clips, gets distorted. So the single biggest technical jump in these reissues is that they run on 18 volts DC power.
Okay, 18 volts. Most pedals run on 9 volts, right? Why double it? What does that get you?
Headroom. It's all about headroom.
Explain headroom for us.
Think of it like the space between your loudest signal and the point where the circuit just can't handle it anymore and starts distorting or clipping. By running at 18 volts, these pedals get exceptional headroom. I mean, the 10-band is rated up to plus 18 dBu.
Whoa, okay, plus 18 dBu. What does that mean in, practical terms for a guitarist?
dBu is just a pro audio way of measuring voltage output, but practically. It means you can plug in a really hot pickup, like a high output humbucker, run it through the pedal, crank those frequency sliders way up to boost, and you won't get that nasty fizzy clipping sound that you often get when you push a standard 9-volt overdrive or boost pedal really hard. The boosted tone stays clean, transparent, which is absolutely essential for, pro use.
That makes total sense. And the other big fix was the noise floor. Those old ones could hiss, couldn't they?
Yeah.
Especially with high gain.
Oh, yeah. They completely overhauled the insides. Better op amps, much better grounding techniques, dedicated power filtering. It all dramatically reduced that background noise. The result is pretty impressive. The 10-band spec is less than 90 dB, so even if you're running into a roaring high-gain amp, the pedal itself just stays quiet. Silent, really.
Nice. And they both got the modern touches, too, right? The bright LEDs, true bypass.
Yep. Both have those nice bright blue LED sliders. You can actually see your EQ curve on a dark stage, which is great. And true bypass switching. So when the pedal's off, your signal stays completely pure, doesn't mess with your tone.
Okay, let's zoom in on the M109S 6-band EQ first.
Yeah.
The smaller one. This one seems like it's all about brute force in a compact package.
It's definitely the mid-range specialist, yeah. You only get 6 bands, right? But those bands are laser focused on the absolute core of the guitar's frequency range. 100 hertz, 200, 400, 800, 1.6K, and 3.2K. It kind of ignores the really deep lows and the super high airy stuff. It goes straight for the guts of the guitar tone.
And that focus is where the power comes in. Because it's narrow, each band has a huge range, plus or minus 18 dB. That's massive.
It is massive. That's 18 dB. That's, 50% more boost or cut per band than the 10-band offers? That's why we call it aggressive.
Yeah.
It's less about subtle tweaks and more about really transforming the tone. The Darbarian's choice, maybe?
Yeah, and players like Zakk Wylde, who famously used the older versions, They weren't exactly known for subtlety, were they? They wanted that punch. So how did guitarists actually use that kind of extreme power? Give us the how-to.
Okay, common example, high output humbuckers. They can often sound a bit woofy or boony down low, right? So you can take that 100 hertz and maybe the 200 hertz band and just slash them, cut them by, say, 10, even 15 dB. And the result isn't just less boominess, it actually tightens up the low end, makes it feel more focused, more articulate, especially important with high gain.
Right, keeps the mud out. And then there's the classic metal scoop sound.
Ah, yes, the scoop, probably the most famous use case. You boost the low end, maybe 100 and 200 hertz for that thump. Then you drastically cut the mids, usually around 800 hertz. That's the frequency that really puts the guitar front and center. And then you boost the high mids, or highs, like 3.2 kilohertz, for that presence and pick attack. When you carve out that 800 hertz like that, the guitar kind of gets sucked back, creates this huge hollow roar. Very metal.
And it's super useful, like our sources point out, if you're using older amps, like old Marshalls, Tweed amps, things without very sophisticated tone controls. Putting the 6-band before your distortion pedal can totally change how the amp reacts to the gain.
Exactly. It shapes the character of the distortion itself, which is why it often gets used as an always-on pedal. It's small, powerful, and just fixes the core mid-range.
Okay, so both pedals have that crucial 18-volt headroom, but the 6-band is all about that focused, aggressive mid-range power. What happens when you take that same core tech, that same quiet operation and headroom, but stretch it out across the entire audio spectrum with the M108S 10-band?
Well, then you get the Surgeon's tool. The M108S is really designed for comprehensive control, total utility. You've got 10 bands, and they cover everything, right down from 31.25 hertz, which is like subwoofer territory, all the way up to 16 kilohertz, which is way up in the air frequencies.
That's a huge difference in range. But the trade-off is slightly less power per band, right? The 6-band was 18 dB.
It is. The 10-band offers 12 dBs of boost or cut per band. Now, that's still a lot of control, don't get me wrong, but the emphasis shifts a bit. It's more about precision across that whole wide spectrum, rather than just raw, concentrated power in the guitar's main frequencies. This is more for the tone engineer type, players like Petrucci or Dave Navarro, maybe, who really sculpt every little detail.
Makes sense. And that slight reduction in sheer EQ power per band is, well, it seems more than made up for by the extra controls the 10-band has, the ones the 6-band doesn't.
Oh, yeah. This is where it gets really interesting, I think. You don't just get the 10 frequency sliders, you get 2 extra full-size sliders, gain and volume.
Okay, the gain slider. That's not typical on an EQ. What's that doing?
So the gain slider controls the input level before the signal even hits the EQ filters. This lets you adjust how hard you're driving the internal circuitry, the A-lamps. Keep it low for super clean, or you can push it up a bit, add some subtle warmth, maybe a touch of analog compression before you even start equalizing. It's another layer of tone shaping.
Ah, interesting. And the volume slider is post-EQ, right? So that's for level matching.
Absolutely essential because, let's face it, if you start boosting multiple frequencies, especially with 12 dB, your overall volume can jump way up. The volume slider lets you bring that output level back down to match your bypass signal unity gain. Or you could do the opposite. Set the EQ flat, push the volume slider up, and use it purely as a super clean, full-range boost. You can't really do that easily with the 6-band.
And because it goes all the way down to 31 hertz, it makes sense why bass players or guitarists using really low drop tunings would gravitate towards this one.
Totally. They need that low frequency control that most guitar EQs just don't offer. Below 100 hertz, that's crucial territory for bass or extended range guitars. The 10-band lets you boost 31.25 hertz, 62.5 hertz, 125 hertz, add real weight and subharmonic feel that the 6-band just physically can't touch.
And for cleaning up those heavy rhythm tones, you mentioned cutting mud earlier.
Yeah, that sort of 250 hertz to 500 hertz range. That's often where things get boxy or muddy, especially with a lot of gain. The 10-band lets you be really precise. You can notch out, say, just 400 hertz to remove that unwanted resonance without thinning out the low-end weight you might have boosted down at 125 hertz.
Plus, 10-band has dual outputs. That's a big deal for setting up rigs.
Huge utility feature, yeah. Dual outputs mean you can split your signal easily, run one output to your main amp, maybe the other to a second amp, or one dry and one with effects, or feed 2 parallel amp chains. It just opens up a lot of possibilities for more complex setups.
And that combination, the full frequency range, the super low noise, that 18V headroom, makes it useful beyond just guitar or bass rigs too, right?
Absolutely. Our sources confirm it. Because it's so quiet and covers the whole spectrum, people definitely use it in the studio as like a precise outboard EQ, shaping vocals, maybe drum machines, synths, even on a mix bus sometimes, if you want that analog character on a specific track.
Okay, so let's connect the dots here. If we boil it down for the listener trying to choose, what's the fundamental difference?
It really comes down to function versus sheer power focus, I think. If your main goal is aggressive mid-range shaping, mostly for guitar, and you need that maximum 18 dB punch, then the M109S6 band is your tool. Compact, focused, great for hitting the front end of an amp hard.
I know.
But if you need surgical precision across the entire audio spectrum from the deepest lows to the highest highs, if you need those independent gain and volume controls for level matching or clean boosting, and especially if you might use dual outputs for complex routing, then the M108S10 band is the way to go. Its 12 dB range is about versatility and fine-tuning.
Right. And that kind of explains their legacy, doesn't it? That reliability, the clean performance from the 18-volt design. Yeah. It's why pros have kept them on their boards or in their racks for years.
Exactly. They solved the core engineering problems of the originals, the noise, the lack of headroom. That makes them more than just typical stompbox EQs. The value is also in that transparency, that clean boost capability. They work great with guitar, bass, keys, synths, pretty much any source.
Okay, wrapping this up then. We've covered the analog heart, the critical need for high headroom like 18V provides for clean boosting, and how those visual sliders really help, especially live.
Which leads us nicely into a final thought here. Bit of trivia. The M108S10 band apparently was initially kind of conceived as a secret weapon, mainly for bass players, using that deep 31 hertz band. But then during testing, guitarist Zakk Wylde was mentioned again. They actually loved having that extended range, the highs and the lows, so much that they insisted it stay full range.
Huh. Interesting. So what's the provocative thought there?
Well, it makes you think, doesn't it? Given that the M108S covers such a wide spectrum and it's got that clean analog signal path, if you were building maybe a non-traditional setup or thinking creatively in the studio, where else could you put a full spectrum analog EQ like this, beyond just guitar or bass? Could it be the key to warming up sterile digital synths? Or maybe a super precise filter for a noise gate sidechain? Just something to consider, as you're exploring and dialing in your own unique sounds, where else could that kind of control unlock something unexpected?